Hello everyone, so that we've implemented the data warehouse pipeline, now we will turn our attention to machine learning. I'm not going into great details here. My goal is just to show you two tools that I think they will find them very useful whenever you need to build models. First of all, let's start by installing the modules here. We have Dataprep, which is used for data exploratory, and Pycaret is used for building models and do a lot of stuff. It has many features that helps you to run machine learning model fastly and also optimize the time for you. And you just focus on machine learning parts. I mean, the statistics and mathematics stuff, rather than coding and burn your brain to figure out what parameters you need to use or what line of code you need to implement. So after installing the modules here, we need to import some modules like pandas for reading the data frame, PyWBC for connecting our Python with SQL Server, Dataprep, and also Paycaret using the regression models. Whenever we want to connect our Python with SQL Server, we need to specify the server name, which is like this is my localhost server name. This is database, the name of database, and this is the connection. So here we're connecting using PyWBC and the function connect to connect our Python with SQL Server using the server, the driver SQL Server, the server name, and the database. For the query here, as you see, we are selecting the date, the month name, the year, and the term label, and also the definition of the term, and also the area, sub-area, latitude, longitude, and type, and finally the result. And if we're gonna see the query here in SQL Server Manager, and we execute it, you're gonna see that we have the data. As you see, the month, so it's just a number here, and the month name is this, which is a string, the year, and this is the what type of test we used, and the area here, the sub area, and latitude and longitude. Those are so important to identify the geolocalization, and this is the type and result. This is a query that we use it on top of the data warehouse table. As you see here, we have the dimension of location. So there are some IDs that so we are joining those IDs with the factor table from the sense and time fact table. So after reading this query, we're going to load it in the data frame by using Panda. So we read the SQL, and here we specify the query, and here the connection, which means the database that we are connecting to. And now if we run this two command here, okay, after just running these two cells here, we need to run this cell just to see the first 5 rows. As you see here, we have the same columns and the same result as we had in the query in SQL Server. So before jumping to the analysis here, I need just to my analysis is going to be based on pH. So I'm going to lock my data frame here on pH and get rid of these 2 columns, determine, definition, and label, because they are not important in our analysis. So we run this cell here, as you see. So we have only the result of pH. And now the magic in Dataprep. So Dataprep has several functions. I'm going to use only create report here and plot. So create report use in backend Flask application, Flask module here to create a web application on Jupyter Notebook. And we need to pass parameters pH and EDA or whatever things you type here is just title for your web application. So we run the cell here. It's gonna process and create the graphics, all the statistics stuff or the graphs that we need to analyze our data. So as you see here, we have a small main menu here. For example, in the overview, it gives you all insight about your data. For example, the number of variables, the number of rows, the missing cells, the duplicate rows, and also the size of your data in the memory, which is very important here. And also we have some dataset insights, like for example, in the result here, it tells you if your data is skewed or is normalized, and other type of information based on your other columns. And also we can like check each variable and its reports here. For example, in the date variable here, it tells you that it is like a categorical variable here. It gives you all the details. For example, like here is not important to know about the mean here, because it's like just categorical variable here, but it gives you other graphics. For example, it plots you like a chart here, a pie chart here, like all other information that like you need to write the code for to just run them. For example, you use Seaborn or Matplotlib, I think, for doing this. So Dataprep like minimize the time and the code to write to have this kind of result. Also, we can see the other columns here. So each column, for example, here we can now like have details about these data, and like statistically, descriptive analysis or other type of things we need to understand. And also we can have correlations, and here the missing values and what are the count of missing values for each variable. Another function that I'm going to use, which is plot, because I want to use it based on result, because we know that our result is skewed. So I just want to know what kind of outliers and how much outliers we had here. So we need to pass the parameter ph here and the name of variable. So we run this function here, and it gives us some statistics. As you see here, it gives us like the descriptive statistics, the mean, the standard variation, and other statistics on data. It gives us the quantiles, and here it gives us the histogram and the KDA plot, and also the both plot that help us to identify the outliers. So as you see here, upper whisker here is 8.8 and the lower whisker is 6.9. So all this data here are outliers. So if we check our outliers, it's about 483, which is like around, I don't know, 14% of the data. So we can delete them. It will not affect our data, of course. So just delete them. We're gonna run this cell here, and if we run again this function, we're going to see that most of the outliers just gone. We have some other outliers here, but it will not affect our data. So it's up to you. It's up to your goal or how you want to run your model. Now, as we see here, literally Dataprep makes it easy for you, especially if you are going to a hackathon or a competition for machine learning, or maybe, I don't know, in Kaggle, or you are a freelancer. It really helps you to analyze the data without writing too much codes and just going to Google some errors, or especially using Matplotlib or Seaborn or other tools to visualize your data and use data exploratory. And now we're going to pass to another magic, which is Paycaret, a module used for building machine learning models and deploying also machine learning models. So before continue, we're gonna talk about those two cells. I'm just using it to avoid displaying the warnings and the errors in Jupyter Notebooks, just to make the file clean and beautiful. So, and also before jumping into the code using Pycaret, I just want to check the website of Pycaret. As you see here, it's used for data preparation, model training, hyperparameter tuning, analysis, model selection, and other stuff. And as they mentioned in their documentation, that Pycaret is used for professionals who want to build rapid prototypes and experiment their machine learning models or data, and also for students and enthusiasts. But it's also very important for people who participate a lot in competitions like hackathons or Kaggle competitions. It saves your time, and especially doesn't require you to remember all the codes and line of codes. And what's beautiful of this module here, as you see here, we have modules, different modules for supervised machine learning and supervised machine learning, time series. We have classification problems, regression problems, and other stuff. And also we have data processing here, scaling and transforming, feature engineering, and feature selection. And what's the beautiful about Pycaret here is the deploy mode. we can deploy, our model in different way. We can here, as you see in documentation, give me 1 second here. Yeah, so we have like we can deploy in cloud system like AWS here or GCP or Azure. You can also save your model and load it next time to just test your other data and predict them. Also, you can save your model as an API. Create your own API here and use it for your website, like an HTTP request to predict whatever you want. And also you can create your own Docker image and save it, push it or load it to your cloud, your private cloud of your company, then use this image to predict your business. And finally, you can create like a small prototype application here just to test it and see your model, how it looks like in projection. Pycaret is very beautiful, and to use it's very simple here. We just need the setup environment for your machine learning here. You use pH here, which is your data frame here, and for result, which is like your target value, what you're going to target as a predicted value. And here we have other parameters. This is what we call it like a default parameter. To use the other parameters to make your model perfect, you just need to go to Paycaret and read documentation carefully. And also there are so many tutorials and blogs about this module. Yeah. And now we need to run this cell here just to set up our environment here. Yeah, sorry, this is what I was talking about. This is the warnings that I don't like to see in my Jupyter notebook. So just to get rid of them, I need to run those two cells here. So as you see here, whenever we run this cell, it gives us some description about the setup environment. So it gives us like what is our original data shape. If there are like missing values here, it tells us like there are 2 features numeric variable and 5 features categorical. And other stuff like if the data are transformed or not, if they are shuffled, if like there is cross validation here, like they are using the key fold here, and what are the number of fold, like the CPU jobs and etc. So all this information, like if there are PCA, like if there are like reduction in dimension variable here. So as you see, like there are too much variables here. You need to read the documentation and try to implement whatever suits you. And after like setting up the environment, now we can launch our model. And to like use the best model, we need to use the compare models function and give it as a parameter sort. Here sort, just put your metric and it will sort your models based on the best metric the model has, like for example here R2 square. And now if we launch our cell here, it's gonna process all the type of regression models like linear regression, XGBoost, CutBoost, random forest, and other type of models, and try to sort them based on this metric. So after running all the models here, as you see, we have the random forest regressor, the best model that offers 0.5 as a squared error here, R2 error, And we can improve this metric here by tuning the models or stacking it or ensemble it. Whatever you want to use the techniques for machine learning, you just read the Pycaret documentation. You can find all the function there. For example, I can like here tune the model, but I will not execute this cell here because it's gonna burn my computer, because you need like at least a good computer for running this model, especially if you have a big data set, or maybe use it in cloud services, for example Google Cloud or AWS or whatever you want, cloud you have. So after like having this model here and you are satisfied with your result or your metric or whatever you want, you can save this model by a different way. Like for example, you can save it, then you can load it next time and just predict the data, or you can create an IPA and Let's see the first way. I mean, saving the model. I just saved the model, so I don't need to save it again. And now we can run this model here. So we just load the model here, and now we can predict it. So what I'm doing here, I'm just reading the CSV file, contains the data in 2017, and we try to predict those data and using like prediction, the prediction function. So if we run here, as we see here, the date, and it gives us like all this is all the parameters that we need to push in our model, and it gives us like the label, which is the result of this features or columns. And if you want to use an API, we have like one application, and we want to deploy it in server. We can create an API using create API function. So as you see here, it creates us a Python file that contains two functions: a home function that is for test, and a predict function that contains the model parameters, and also the panda that read these parameters and convert them into data frame. Then it uses Paycaret model to predict those data, return the predicted result as a JSON format. And this JSON format, we can use it as the result. We can use it in our website or mobile application or whatever thing that we are going to represent. So we run our API here. So we are running the server. Okay, now the server just launched. I'm going to show you what I mean by the homepage function here. So I'm going to here. I'm going to run this link. As you see here, this is the JSON format, as I mentioned. So it gives us a message because we write here. There is a message here. We return a message, and the message says hello world. So this is how what we are going to expect the result of our predict function, and we use that result to just render it in a web application. I just downloaded an HTML template. It contains a form, and this form I modified to be able using it for my model. So we have the date, the month name, the year, area, and sub-area, latitude, and time. And we have here the result. So whenever we pass the parameter and send the message here, which means like send the request, it's gonna be converted to the server and load for us the result. So let's just back to our model and try to pick just some variable. I don't want to get all the data from from the server and from the website and try to build this schema and try it. I just want to just test it in my data frame, all data frame. So what we are going to do, we are going to copy this parameters here, which I've already done it here. So I'm going to copy the date, and I'm just using my cache, so it can be fast. Okay, latitude here and latitude. So if I'm running here, I'm going to send. We are having our result. So let's just understand what just happened. If we check the inspect element of the website here, we just we just query that data from the server here, as you see, and we get a result as an object here, as you see. So this is the result as in a JSON format, and we render it in our HTML page using fetch command and inner HTML to just run it. So as we see here, we just predicted based on this data the result of pH of that location and a specific date, which is 8.03. And if we go here, like the first data, it's 8.02, which is not so far. There are some errors because our model is not that accurate. As you see here, we have 0.5. It should be like perfection. I mean, you can perfection this model. So as you see, it's very simple to use. It's very like friendly user, and especially as I mentioned, like it's gonna help you, especially whenever you want to prototype your model, have a fast response, or you're working on computation, it really helps you a lot.